So access control models, RBACs, Solaris was the first to implement role-based access control. Next, we've got technologies. Organizations select access control models based upon the business need and objective, or the mission. What's the purpose here? There's different ways to implement access control in general. You have role-based, rule-based, restricted interface. This is a common CISP topic. Capability tables and ACLs, those are really, really easy. And then, of course, content or context-dependent access controls. So here's an easy one. A rule-based firewall, when you put in parentheses right here, firewall. It's an easy way to remember. Rule-based.
Rule or role?
Rule, R-U-L-E. There's two RBACs. There's a role-based and rule-based. Firewall is a type of rule, a rule set on the firewall, rule-based access control. But it's also a type of mandatory access control because it's applied globally to anybody that wants to go through that firewall. Everybody has to get inspected. Do you agree with that or disagree? So if everybody has to get inspected, then it's mandatory that you meet my permit list before you get through the firewall. So rule-based access control equals firewall. You can use role-based access control with MAC or DAC. Again, look at your keywords. MAC roles can be developed and sensitivity labels assigned to those roles based upon the security levels. Whether DAC roles can be created and the data owner can choose. So the same keywords apply. DAC, data owner's choosing, and mandatory access control, the decision's based upon the device label or security label or sensitivity label, whatever it is. If it ends in label, it's MAC. Then you have a rule-based. This is a type of mandatory access control. Okay, funny enough, look at the example. Firewall. Firewall policy might specify that all traffic is dropped except for HTTP port 80 or SMTP. These are just different types of decision making. Basically your firewalls make decisions on source and destination, IP addresses, and ports. Any questions? Then you got restricted interface. There's a couple different ways to restrict interfaces. Like, for example, menus. Have you ever gone to a Windows system and click on the Start button, and sometimes you have the Run dialog box and other times you don't? Mm-hmm. Basically, a group policy was set that, or local or global, it doesn't matter. But a group policy was set somewhere that basically says, hey, remove this menu. Or you click on your file menu and it's shorter than other file menus. You're using policy to control what menus are available. Or what commands within a shell. Who can use the switch user command, for example? You could also do it on the database view, which is more of a, if you're doing it on the actual database itself, it would be more content-dependent access control. But you could also do front-end restrictions, which would be context-based access control. Or there's another one called physically constrained interfaces. And the best way to describe this is really ATM machines. Physically restrict who can do what. Like, do you want every user to be able to mess with an ATM? No, a regular user shouldn't be able to manage the ATM, or else there'd be no money in it, for example. So physically constrained as well. This is where things like elevator hacking come into place. You ever heard of elevator hacking? You guys will be hacking elevators by the end of the day. In theory, you can
speed up this one a little bit. If we hacking, we'll make this one go faster.
Can't make it go faster, but what you can do is hit the closed door button in the floor you want to go on at the same time, and it puts the elevator in administrative mode, and so it'll drop you off to your floor first and then drop everybody else off. So that's pretty convenient in New York when you got 30 floors to travel. All right, you basically get dropped off at your floor first, and it's always great when you do this in an elevator and there's a bunch of people on, because they're like, it's not stopping, oh my god, the end of the world. And then it's, the door opens on your floor, you get off and you're just like, have a nice day. So and then everybody else is sitting there scratching their head.
All at the same time?
Yeah, all at the same time. It works well on Otis elevators.
Nice for
I'm
summer
sorry,
weekends.
you do which ones? The door open?
Door closed
closed,
and the floor at the same time, and then both will beep. Or you could just go to YouTube and search elevator hacking or vending machine hacking.
You know, we all gonna try it.
Internet is a
Excuse me, I have to go.
Yeah, we all
I
gonna
need to
try
go
it
to the
since we
bathroom. I'll
leave,
be
right?
right back.
Sure, all right, there you go. Go play in the elevator.
My alarm go off.
Menus and shells, right? You're going to limit the options for the subject inside the system.
You have way too much free time.
Remove certain features, not displaying all of your applications and/or menus. And for example, on a Windows-based system, you could remove the run command or the start menu and hold together, or what's available in Control Panel, or what's available in Internet Explorer. There's a ton of ways to actually implement this. All right, you can do it on database views. Now, don't freak out. The concept here is not these are just schematics for databases. But you could restrict, for example, a specific table in a database and who can view it and who cannot. So that's the big picture here. Custom ways of looking at the data, rather than giving everybody basically full permission to all of the data. Then you've got physically constrained, only certain keys or functions are available. So like only the number key, only certain users can touch certain screens. For example, at a kiosk, I remember in the early days of like Best Buy, and they used to put the little floor models of laptops there, but they used to customize it and basically put a policy on it. But if you knew how to bypass the policy, you could basically get into all the full features. Nowadays, they just more or less give you the whole laptop in the store. Sometimes they use demo modes, but there used to be certain features. You used to hit certain buttons, and you could get out of the demo mode and have full access to the operating system.
I bought a laptop, a model laptop, and it had an admin password on it, and they couldn't figure out what it was.
Password.
I don't know. I mean, but they couldn't figure it out, so I ended up having to order a
Restall this.
restall disk and restall the entire operating system and everything because they couldn't figure out what it was.
Yeah.
I tried the password cracker and everything.
Then you got capability tables, an element that defines what actions a subject can perform on a different set of objects. So I'll show you this in a second here. The easiest way to describe this is the capability of the user is really the row in a spreadsheet. So you have a think of let's do here.
Sorry, which of the three general types would this be?
The capability table.
Yes?
This would be capability tables and access control list.
Yeah, but you've got three general types of access controls: menu, shell, database view, and physically constrained.
That you're referring
That
to
one, yeah.
these guys right here.
Oh, that's just.
These are types of restricted interfaces.
Oh, okay. Never mind.
That's the difference. So menu shells, database views, and then physically constrained. And then we move on to the next subject, which will be capability tables. And think about the capability of the user. So what a capability looks like, it looks like an access control list. So normally in an access control list, you have Leo and then the object. So what can Leo do to the object? Leo can read the object, for example. How that differs from a capability table is there's multiple columns. So it's Leo's complete capability, all of the objects that Leo can access. That's Leo's capability. So you have a capability table, meaning everything that I can access is documented. And it's with the subject. The subject will be the first column, and then each additional column would be the actual object. So file 1, file 2, file 3, file 4, they would all be different columns. So when you look at the capability of the user, what can Leo do to file 1? Read it. What can he do to file 2? Write it. What can he do to file 3? No access. What can he do with file 4? Full control.
So is that for? That's for just one resource. What can you do within?
Well, it's multiple. Capability tables are multiple resources. Every resource is its own column.
Right, but that type of access control, would it be what you're allowed to do on an entire enterprise? Or is
Could
it
be,
focused? Okay,
Yeah, if you want to map out every single object in the enterprise, that'd be a lot of columns.
Yeah.
But sure,
and
why
it's hard
not?
to manage.
Is this this capability table? Does that get fed by whatever permissions
Of the user?
These subjects get issued?
Yes.
I mean, so you're not necessarily as an admin or whatever like defining this out like in an Excel document.
An Excel document's a convenient way to look at it. So let's do. No, we're just doing this sheet. Let's do it this way. Leo, Tom, and Jerry. That'll be your first column. So file 1, file 2, file 3, file 4. So I'm just going to make up stuff here. Read, write, full control, no access, full control, and write. This is an access control list. You go to the security tab of any one file, you can add in the user and what they can do. Agree or disagree? Yep. All right. But I can look at the capability. Whoops, I didn't even do Leo in that. Read. Let's just give Leo read everything. I can look at the capability of the user, and that has to do with all files. So this is a capability table because I'm looking at all the capabilities of Leo, Tom, and Jerry.
So it's access and authentication, access and authorization.
Oh, we'd have to be authenticated first, but we're talking about authorization because it's permission-based
Right.
or functionality-based. What can I do? Once I'm logged in, what can I do? Well, the capability of Leo says that Leo can read everything. But the capability of Tom is Tom can read, write, no access, and full control. So capability table is the whole thing. Access control list would be one piece of it. That's the easiest way to look at it. So if we go right-click properties, go to the security tab, well, normally we stare at an access control list. But if I were to build a capability table of everything that the subject can do, well, then you have a capability table.
I just don't see the context.
Well, I want to control what you have access to. So every time I give you access to something, I have to add in a new column, basically. If you tried to implement it using this, it would be pretty manual and painstaking, but it is a type of access control. So you'd want to use something like a directory service that would facilitate
You
this.
want to hire somebody else to manage it.
Yeah, hire somebody else.
Well, I guess that speaks to the question that I had regarding.
Go ahead, ask your question.
It gets so it ingests whatever type of authorization did it and built it based on the tool that you're using to do that, like Active Directory.
Yeah. Yeah, you wouldn't want to do this manually. I mean, I guess you could do manual permissions everywhere, but try to grow that in an enterprise and you see how that's going to fall apart real quick.
Well, if you do it at the file level, but you could do it at the directory level or
Sure.
whatnot.
Yeah,
Inherit.
that would be a lot easier to do, as a matter of fact.
I did a question last night, but I think you got it wrong answer.
You want to review it now or you want to do it at the end?
I'll do it at the end. I don't remember which question it was.
I'm waiting all morning to tell you that.
It'll take me a few minutes. It's in the first 50 questions, and then it's like take a few minutes to find it. But it's
Fair enough.
But I think they have the wrong answer.
On my side?
Yeah.
Fair enough. We'll do it. So here's your access control list.
He's trying to get bonus points here.
There's no bonus points, buddy. All right, so access control list, right? Here you go. Here's an example of an access control list. So this is, again, based on authorizations because it's permission, but you could authorize someone basically on the user or the group level if you wanted to. Do you agree or disagree?
Agree.
Concur. Then you got the access control matrix. This is often in discretionary access control. It's a table. It's a whole table. So circle the word table. That's going to distinguish between the two. So it has the following elements: the capability of the user, or in the access control list, which would be the permission. So think of it as multiple access control lists. So an access control list in itself is singular, and then a capability table is plural in that sense.
Okay, how does a capability table differ from an access control matrix?
Multiple columns.
So they both have multiple columns. Capability
Access
table also
control list has one column.
No, access control matrix.
They're almost interchangeable in that
Okay.
sense.
All right.
Yeah.
That's an access control matrix. And then columns have
Right.
But it could also be
That's the rows.
capability.
An access control list would be one column.
Right.
And then you have an access control matrix here,
Right.
which is the whole table.
Which is similar
But
to
the
a...
capability table is really focusing on the row, the capability of the users. It's still an access control matrix.
Okay.
Yeah, because an access control matrix in itself, by definition, is a framework.
Okay.
But the capability is now filling in that framework with what the user can actually do, which is a great question. And please ask your questions, because if I can make something easier for you, hopefully that's what I'm trying to do here. If I can make something easier for you, then let's do that. This is, of course, a lot more harder to do because, as your concern was, well, how the heck am I going to implement this? And it's very, very hard to do with a large amount of users. So when we had 15 user node networks or 15 computers in a whole company, well, there you go. It's pretty easy. It's easy for the admin to go around and add permissions here or there. Now that we have thousands of computers, good luck.
So I mean, that's kind of to the point that you made, that some of this stuff you learn because you need to know it for the test, but you might not ever.
Yeah, now it all depends on you and your experience and what you want to do with your career. But as a security professional, we cover all of it, and then you get to choose when what is applicable. So then you have content-dependent access controls. So this would have to be on the database itself or on the content in itself. Commonly found that, hey, funny enough, databases and firewalls. All right. So when it comes to administration, there's basically three different types of models: centralized, decentralized, and hybrid. Centralized meaning that you administer everything in one location or one central source, and then decentralized would be you don't manage it in one central source, it's decentralized, and then hybrid would be a combination of the two. Let me give you a great example of a hybrid. You guys are familiar with like the little insurance companies, like your Allstates, and each basically person has their own office. So you have your own local agent, and they're like a little franchise basically. Well, they have to manage all of their own resources. They want printer paper or anything. They're basically out of the element of the corporate office. So good luck. You got to go get that stuff yourself. You got to administer all of your own systems yourself too. So you got to want a new printer, that's up to the agent, and they can go certainly install a new printer. Nobody's going to stop them for that. They don't have to get corporate approval. But in that decentralized model, they all connect to a centralized, for lack of a better word, mainframe or centralized resources. So then they want to add your account into the Allstate database, they have to do that in the centralized location. So the user data piece of it is central. The administration of the resources is local. So that's a hybrid model. And you'll find out with those in small insurance agencies. So I'd rather give you something that you can relate to. And if you ever go into your local insurance office, look around. You'll see them open up. Anytime you see them open up a terminal to access the corporate resources, or we're talking about or hybrid, or a combination of centralized and decentralized. So centralized. One entity determines the access level of the subjects in a single location. You can have multiple locations, but it has to be centrally administered. And some technologies that you can use here are Radius and TACACS, and those are definitely very important within the scope of CISSP. Radius stands for Remote Authentication Dial-Up User Service. It was our old dial-up method, so you wanted to get to your corporate resources, you had to dial up to the corporate office. Nowadays, that's more or less been replaced with VPNs. And then you got terminal access control systems, and there's a couple different ways that you can do this. There's TACACS, write this down on the sideline, just regular TACACS, TACACS, and then X, TACACS. So TACACS with no plus, and then an X in front of the word TACACS. There's just other models. But I've been asking people this question for a while, and I can't seem to get an answer out of anybody. Does anybody ever heard of anybody using TACACS or X-TACACS, not TACACS Plus? Exactly. I'm pretty much convinced that TACACS and the X-TACACS are dead. At least they have been for the last 2 years. I've been asking that question. Nobody's using them. I mean, maybe there's somebody out there, but don't hold your breath for that one. TACX Plus, this is a Cisco proprietary, using Cisco and Unix environment. This is a Cisco proprietary protocol. And a couple of the major differences, write this down, splits the AAA database, AAA, splits the AAA database. So it uses a separate database for authentication, authorization, and accounting, where Radius, this is a combined AAA database. It uses one database for authentication, authorization, and accounting.
So it splits to AAA.
Yes, split. TACX Plus splits basically 3 databases, so it splits the AAA model out. So it's a little bit more scalable because you've got 3 separate databases rather than one. Radius just used one database, and that was typically an Active Directory server. And we're going to take these apart here in a couple minutes. Another obvious one to put down here in the summary pages here is can I give you an easy rule of thumb? Absolutely. This rule of thumb works pretty good. If it has a C in it, chances are it's connection oriented.
What has a C in it? The name?
TACX has a C in it, so it's connection oriented. And what I'm referring to is TCP versus UDP. So TACX has a C in it, it uses TCP. Radius has a D in it, it uses UDP.
Say that again.
TACX has a C in it, so it uses Transmission Control Protocol, TCP. Radius has a D in it, so it uses UDP. Now, of course, they didn't pick that because it had a D in it, but that's the way we remember it for the exam. A little low-hanging fruit like that. I'd rather you go, I need something that's connection-oriented. I'd better pick an answer with a C in it, because 9 out of 10 times that stupid rule works out well. That's more a test-taking prep thing than anything else. So how do you remember which one's TCP versus UDP based? Well, if it has a C in it, chances are it's connection-oriented. Like IP. IP has no C in it, so it's connectionless. All right, so here's your Radius example. Let's look at Radius for a second. Now, you got the internet out here, and people are connecting to the corporate network over the internet, for example, or in this case, they'll be dialing up, but nonetheless, they're over some cloud. Would it make sense to put your directory services database or the Radius server, which has your credentials database, would it make sense to put that over here on the internet, where anybody on the internet can attack that server? Yeah, right?
You always want to reduce the attack surface.
Right, you always want to reduce the attack surface, exactly, reduce that. So what they do is they basically split it into the Radius client and the Radius server. And so anybody can talk to the Radius client, but there's nothing on it, other than a rule set that says who can talk to the Radius server. So you basically split it out. Who can talk to the Radius client versus only the Radius client can talk to the Radius server. That prevents regular people out on the internet from touching your corporate network internally, because of the way the rule set is mapped out. So you could think of a Radius client as a front end, so you might want to write FE here, front end, and then the Radius server is the back end or BE. So just front end, back end model, and that's a lot easier to get the Radius client versus the Radius server. The Radius server would be the back end, or where your directory database is, so all of this would be back end, and then the front end is what the users touch, which would be your Radius clients. What they don't show here is that there would be some sort of DMZ, and the Radius client would sit in the DMZ, and then you have some firewalls and routers and switches and everything else to map this out architecturally. So right now we're just trying to focus on the client versus the server, but to realize that the Radius client is going to sit in that DMZ, which the users can touch, but the users can't touch your internal network without getting authenticated and authorized through the DMZ. And that's how you control access to corporate resources on a dial-up network. Make sense? Agree? Disagree?
Agree.
All right. So here you go. Two possible scenarios for radius. You got dial-up corporate access. In this case, the client's going to connect to the radius client and present his identification, get authenticated, and then it'll get authorized between the relationship of the radius client and the radius server what you can do on the corporate network. That was your dial-up example. Then you could also do this, a client talking to the radius client, again to the radius server, but now you're doing this over an internet connection as opposed to a dial-up connection. And then again, you get identified, authenticated, authorized, and then you can touch the corporate network. So one's dial-up, one's over the internet. And I don't know who's dialing up still, but I'd imagine there's still some people doing that.
Those industrial control systems, they still have nowadays.
Who does?
Industrial control systems.
It probably serves some sort of strategic purpose, or it's just antiquated. It should be outsourced.
It's antiquated.
Okay, well there you go. It's antiquated. Well, maybe it's a cheap alternative. I mean, maybe, I don't know. Maybe that's why they still have a cost. You can throw cost, politics, money, religion into that. Then you have decentralized, which are basically, I already talked about this. But a security boundary in Kerberos would be a realm or security domain. So you can have each location its own domain if you wanted to, and that's another way to do decentralized access control. And if you got hybrid, I already gave you an example of that. That was your all-state example. All right, access control methods. Access control can be implemented at different layers of the network. You can have core components of the operating system do it, you can have hardware functions, or you can actually have third-party add-ons. So, access control can be broken down into functional areas. You could have physical controls, administrative controls, and technical controls. So, hey, jump for joy! Guess what? Palto model comes back into play again. So now how valuable is that? Anytime you get to reuse your models over and over and over again, they become more important every time you can do it. So anytime you see physical, administrative, technical, or logical, or operational controls, same decision-making process for your answers. So now, anytime you see the word control, that should get you all warm inside, because that means you can use the Palto model for filtering your answers. Because they're talking about controls, physical controls, administrative controls, technical controls. So, let's talk about these. Do these make sense? If I say administrative controls and you look at these, do they make sense as administrative controls?
Testing?
Yeah, validation testing. You could say the actual content of the test would be a technical control if that's what you're getting at.
I'm trying to figure out how it's an admin control.
We can have a policy that says we're going to test everything before we go into production. So you can't just take your code and put it right in production. You got to test it off first. That's an administrative process.
Okay.
Highest level. Don't get in deep, because as soon as you go 1 inch deep into this, then it basically, all the content is now going to be either technical or physical. Highest level. Would you agree that these would be physical access controls?
Yes.
Network design also could be technical access control, though.
Yeah.
You know, architecture, logical or technical. But in this case, when we're talking about physical, that means that you'd have to physically separate secret from top secret. Backups, physically backing up your data, physical cabling, physically work area separation. The easiest way for you to visualize work area separation is to think of a manufacturing plant where they build the engines in one place, and then they build the transmissions in another place, and the tires in another place, the frame, the body, and then eventually all of that's going to flow together and create a car. You know, if you think about it that way, it's pretty easy. But you could do the same thing in an IT environment. You just would separate network communications from datacom, from firewall, from security, from everybody else. Technical, also known as logical, jump for joy. So you could also logically do network architecture or virtual LANs, VLANs, network access, encryption, control zones, honeypots, auditing. But auditing could also be physical too, right? You have your physical paper-based audit log, like when you sign in at the front desk. That's a physical control. But then you can also have computer-generated auditing, which that would be a technical control. It's more importantly, a detective technical control. Question?
Yeah, what do you mean by that?
What, the last piece? In other words, something, let's take the concept of auditing. Well, but prior to computer systems or technical controls, could we audit? Sure. Could I have a manual sign-in log? And if I wanted to go to that manual sign-in log and actually pull out the physical piece of paper and look on that log, I could say, Mickey Mouse was here. And then I would, because I actually had Mickey Mouse sign my logs one day, and I had to go track down who Mickey Mouse was and have a talk with Mickey Mouse to say, Mickey Mouse, you shouldn't be signing as Mickey
Send me to
Mouse.
Disney World.
Right, or I want to send you back to Disneyland, basically. Don't be doing that stuff. Because Mickey Mouse was boasting how, they don't check security here, this is blah, 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 blah. Oh yeah, all right, Mickey Mouse and I had a little talk about that. What are you doing? Of course people aren't going to respect security if you're signing in as Mickey Mouse. What kind of example are you setting, Mr. Security Guy? Go back to Disneyland, right? But let's fast forward 20 years and now we got all these computer systems. Computers can generate logs, right? Those are technical systems. So now that's the difference between physical and technical. Make sense? All right. Auditing in itself is considered a detective control. But let's walk through the decision-making process. It is a good idea to cross-reference this. Here's the Palto model. So technical access control. In this case, we're talking about auditing. So if you knew that I was auditing, would that prevent you from doing something bad? So in this case, it would be a preventative control for you. Would anybody else agree or disagree with that?
Well, it doesn't have to.
It's actually going to physically prevent you from doing something bad.
No, it's not.
Okay, so
Not
all right,
physically.
it's not going to. Is it going to technically? No, it's the control in itself. The fact that we're auditing is not going to prevent you from doing anything
May
bad.
deter, but not prevent.
Okay, so if you knew that I was auditing and looking for bad stuff, it may deter you. But also, if you don't know that I'm auditing, it may not deter you.
True.
Okay? But in the event that I am auditing and it's turned on, at least now you have a place to go where you can look to see who did what, who logged on, who failed their log-ons, who tried to access this and couldn't, who successfully accessed this and did. And so you would be able to detect something that went wrong, both in the physical sense and the logical sense. See how I walk through this? Right? But let's humor the scenario. And the audit log in itself, the technical audit log, is that going to correct the situation?
No.
Is it going to recover if something goes bad? Is it going to recover something? No. It's always a compensative because everything's compensative. And directive controls are administrative, so that's not going to apply to physical or technical. So the decision-making process of the Palto model is more important than the content. More importantly, you can use it as a filter on your answers, on your practice tests, and get some low-hanging fruit there. All right, so, hey, now we throw it in. You guys are already hip to this, but let's make sure that we have them. We have all these? Well, there's one missing. What's missing?
Correct.
Directive. And not everybody puts the directive control in, but since we built the model, the decision-making model, that tends to be very, very important. Compensative controls, directive controls, those are more bonus. The majority of what your decision-making will consist of would be preventative, detective, and deterrent. You can throw in corrective and recovery in there, but those are really optional at that point. So now how important is this on a scale 1 to 10? About a 10. All right. So corporations need to perform routine access control maintenance to keep security at an acceptable level. So types of activities, right? some things that make sense here, should make sense. So let's pick 2 or 3 out of these and go over them. Do these make, and this is more of a does this make sense check. So would you, when it comes to controlling access, would you want to prevent anonymous connections? Yeah, probably be a good idea. Disable accounts after an individual has left the organization.
Absolutely.
Yeah.
Of course, it doesn't happen all the time. Doesn't happen all the time.
Enforce the concept of least privilege.
That also doesn't happen, but yes.
Require password changes, depending on the role probably, but or how many passwords you change, you know. Enforce strict password requirements. Achieve audit logs securely for referencing purposes or detective controls. So does it make sense that these are the types of best practices, more or less than anything else, that you can do to keep security at some level? So these are good ideas, right? All right, so information can become compromised. So how do we how can I get access to something that I'm not supposed to have access to? Could I socially engineer my way to data that I'm not supposed to have access to?
Yeah.
All right. Can I use a covert channel?
Yep.
What is the difference between overt and covert? Covert is a hidden channel. Overt is an in plain sight channel. So if I come up to you and I say, here you go, you can have this. Everybody can see it. That's an overt channel. But the minute I hide it, I'm going to hide this over here, and then you come over here and you pick this up later, that would be a covert storage channel. Malicious code, or just wire sniffing, packet sniffing, packet analysis. You can do this intentionally or unintentionally. Unintentionally, inappropriate rights get assigned. So let me tell you a horror story. A company that I worked for once they wanted to save money. So they fired the senior people that knew what they were doing, and they hired junior people, and they could hire twice as many people. Sound common? Well, these junior people worked there for about a year. And guess how they solved the help desk folks, guess how they solved every single problem they ran into?